Right, so last week we learned about positive and negative numbers, and we learned the addition and subtraction laws of direct numbers, right? And the two laws are, right? The first law we learned was when we have same signs, we add and keep the same sign, right? An example of this, -3, -2, -7, all of them are the same sign, so we're gonna add and keep the same sign. 7 and 3 is 10 and 2 is 12, so negative 12 here, right? And the second law we learned here, students, was the different signs law. And different signs, we find the difference. We subtract and keep the heavier side. Example, -10 plus 2. We have different size clashing here. So we're going to find the difference. We're going to subtract and keep the sign of the bigger one, right? Or the heavier one. So in this case, we say 10 take away 2 is 8. And we keep the sign of the 10. So it's -8. Right? Nice. And as all we did last day, really, we did some practice on it. And we did some explanation as to where we could see negative numbers in the real world, etc., etc. Right? So let's go on to the homework assignment now. Right? Who wants to do the first one? Let me see hand.
Me, sir.
Go ahead. -5, I'm sorry, -3 -5. Give me the answer.
So it had two negatives, so that would equal to a plus sign. So 3 plus 5 is 8, and that would be -8. So
All right. So he said it has two negative signs here. So it's the same signs. I'll give the same sign. Right? Ismail, if I didn't hear you wrong, it said two negatives make a positive or something there.
yes, sir.
So it's supposed to be positive 8 or negative 8. Are you be sure?
Negatives, it's saying as negatives, sir.
Negative 8. Two negatives don't make a positive when you're adding, right? Yeah? Be
Yes,
careful of
sir.
that. Right? Be careful how you say it. But good work. We got -8 here for the first one. Second one, do second one time, Ismail. Everybody going to 2. Right?
A negative and a positive is a negative. So 7 minus 10 is +3, sir.
Positive 3. Right? But I'll listen to the explanation, right? The explanation I want to hear is same signs, add and keep the same sign. Different signs, subtract and keep the sign of the bigger number. That's all I want to hear. Yeah?
Okay, sir.
Right, but good work still. Luke, if you do number 3 for me.
So -9 take away 5 take away 6. So -9, you have to, two negatives is equal to a positive. So -9 plus 5 plus 6, which will be equal to um, +10.
Positive 10. All right. Anybody else got that? All right,
No,
Luke.
sir.
No, sir.
Yeah, no, sir.
No.
See,
No,
that's supposed to be -20, you know.
Right, right. So Luke, your explanation is wrong. Right? Now, what happened is that you're confusing the addition laws with the multiplication laws, right? All I wanted to say for me is the two laws we learned so far is either the same signs law, in which you add and keep the same sign, or the different signs law where you subtract and keep the heavier sign. Right, Luke? So in this case, what I wanted to say is everything has the same sign, everything has a negative, so we're gonna sum them together and keep the same sign, right? Yeah? When you add up this, you're gonna get 20, so the answer here is -20. Right? Next one. Daniel, number 4.
Okay, so -11 plus 25. So because it's two different signs, we would you minus.
Yeah.
And after minusing 25 and 11, you would have 14. And because the bigger number is positive, we will leave it as positive 14.
Excellent proof, right? You want to do number 5 one there?
Okay, so B9 is 16. And well, because both are negative, we leave it as negative 16.
Good. Same signs and actually the same sign. Excellent proof. Luca, why you do back number 6 on?
Okay, so -11 take away -2. So
Look,
w-
-11 take away -2 is this question here. Otherwise, change the question, right? It's very important if you're making mistake now to fix it, right? So this is other way of saying that -11 take away -2. This is -11 subtract 2 or -11 minus 2. Yeah?
yes, so
Nice. Be careful, go ahead.
so -11 plus -2 is equal to -13.
Alright, same sign, same sign. Good work. David, number 7. David, not there. Samir Ali, number 7.
-15 plus 8. The negative number is bigger, so the answer will be in negatives. So 15, I need to subtract. So 15 minus 9 is 6, so it could be -6 for the answer.
After they give me the answer for this one here, right? This one is -7, right? But good work, right? Both questions you're using the different sign flow. Subtraction to the bigger sign. Bostic, the number 9 come on.
Number 9. -25 minus 20. So it'd be 25 plus 32 is 57. So the answer would be -57.
Good. Right. Nathan Bostic, you there? I see your hand was up. Number 10.
Yeah, I do.
Right. Number 10.
So number 10. So it's different. Well, yeah, the difference is -25 and positive 32. So we have to minus, which is positive 7.
Positive 7. Alright, good work. Do the next one time, number 11 come on.
So again, it's the same thing. Not minus, -17 and well, plus positive 24. So that's a minus again, which is what is it? Positive 7.
Positive 7, good. Right, this one here, I'll do the rest here. Right, so we're going to move on to the new topic. So I'm going to go for that speed, right? Pay attention. Different signs, subtract 50% of the bigger number. 100 take away the 7 is 15. So we get -15 here. This one, very simple. Same sign, so we sum them all together. Keep the same sign, -187. This one, same thing. Everything has the same sign. So we're going to sum them again. 6 add 6 is 12. 12 add 17 is 29. So we have -29. Right? And the last one, same signs again. And I keep the same sign. 15 and 2 is 17, -17. All got all correct? Let me see your hands. Right? If you didn't get correct, put it wrong next to it. Put the correct answer. And you revise it and you know what you need to work on. Excellent work. Right, the mixed exercise now. Right, I want to do a couple of these here before we move on to the new topic, right? So the first one here, students, we sum the same signs together. So this is -19 and this is positive 6. And then apply the different signs law. So we apply the same signs law here and then we're going to apply the different signs law here. Right? So 19 take away 6 going to be how much? Well, 15, negative 13. Right? Next one, same thing here. We could rearrange it if you want. Rearrange the negatives first, minus 6. Minus 6, minus 3, minus 2, and then you put plus 4, plus 9, plus 1. Same signs here. We get negative 9, 10, 11, and then you get positive 15. You get positive 4 here, right? Yeah? Right. So I want 2 volunteers to do the next two for us, and we can move on to the new topic, right? Okay, I'll send the answers to you here. So let me go. Isa, there's Saran. You can do number 3 for us.
Yes, sir. So first we group any negatives, negative 2, negative 6, and negative 7.
Yes.
Yeah. And then we group the positives, 1 and 3.
Right. So we solve the negatives together. Where you go with this?
15, negative 15.
Negative 15 is correct. And then you solve the positives. Where you go with that?
4, positive 4. And you minus 4 from 15, you get 11, negative 11.
Excellent, right? Good. Next one, Tristan. Number 4.
So you'll for number 2, right? Yeah, you get the wrong answer. So the answer is positive 3, not positive 4. 4 plus 9 plus 1, that is 14 or 15, so.
Alright, so sorry about that. 14 here.
Yeah.
All right.
And the answer for number 4, right? So basically, you have to add all the negative numbers. So 9 plus 6 plus 7 plus 3, that equals to 25. And then add the positive numbers. 4 plus 10 equals to 14. And then 25 take away 14 equals to negative 11.
Right. I want to show you all something here, right? As for more students, right, how you write your work is extremely important. If you write your work bad from now, you're going to do bad in equations and you're going to mess up equations. That's topic, right? And that's a key topic to algebra. Solving equations, you want to do this term, right? Nice. So when you're writing stuff, be careful. When you rearrange it, move the correct sign with the correct term. So minus 9, minus 6, minus 7, minus 3, everything comes together. Now you don't leave no big space. The question still continues. So you write minus 4 next to it, right? And then you write plus 10 next to it, right? So this is one full sentence here. This is like a sentence you write it. Yeah? So from one line, we went to the next line. And in this line now, we simplify some stuff. So the only simplify to give you a negative 25 and this simplify to give you a positive 14. And then what I did is I write an equal sign and I put my answer, right? So be mindful of how you're writing your work, right? I want to do two more examples here before you move on, right? Yeah? So number 5, look at number 5. Everything you rearrange already for we. So we can simplify this here, same signs. So we get minus 14. Same signs here, we get plus 7. You apply the different signs law, and the answer going to be negative 7. Right? Number 6, again, we can rearrange number 6. We could say minus 8, take away 3, plus 2, plus 7. This is minus 11, plus 9, which is equal to minus 2. So you see from one line to the next, and I put equals to my answer, right? So you can clearly see what the answer is here, right?
Right? Sorry for missing some class.
That's okay. We just did the corrections that you work as you know, coming into number 7 from we go to the next topic. Right? Number 7, look at it here. Right, Colin.
Just I was getting my book, which I had do it in.
Do it here, man. Come. Forget the book, man. Do it right here. Right. We are arranging the negatives together, right? I'll finish. Minus 44, minus 6. Tell me what we getting.
We'll get 38.
Nah. And this is these two terms same sign, right? So same signs you add and keep the same sign. Yeah? So we adding this together.
Yeah, I'll get 50.
Negative 50.
Negative 50.
And here we do the same thing we get.
You'll get 10.
Right. Positive 10, right? Yeah?
Yeah, positive.
Now we have same signs or we have different signs now?
We have different sides.
So tell me the answer, tell me the lower, tell me the answer.
Negative 40.
Negative 40. Excellent, right? Revision is important. All right, start every class, we're going to do a little revision, right? Because if you don't understand this topic, we can't go on to the next topic, right? Good. So you can do your personal revision, and also we need to do revision in class and currently homework and stuff, right? Yeah. Right. So we're going on here now to the next page here now. Colin, as you're on the mic, read for me. Hi, Colin.
Definition of like terms. Like terms are terms that contain the same letter variables,
Mm-hmm.
which are raised to the exact same powers. Only the first number coefficients of the terms are different.
Well, that's not
3a
important.
and
Yeah, right?
3a and 2a are like terms because although they have different coefficient numbers, they have the exact same letter a in them.
Right. So this is extremely important, right? Like terms. Like terms are terms with the same variable. A variable in mathematics is what? A variable is an unknown term, an unknown quantity, right? Now, next week's session, we're going to go more into algebra, right? But today I just want to touch on the surface so we can get started on this new topic, right? Like and unlike terms, right? So let me give one example. We have 3x here, 5x minus 7x, and 2x. Are these like terms here, Colin? More or less here. Are these like terms, Colin?
Yeah, because all of them have the x in it.
All have x in it, all have the same variable. So the variable here is x. The unknown term is x, right? Good. So all these are called like terms. Like terms have the same variable. Colin, if I put in an x squared here, is this a like term?
Yeah, it is.
No.
Because it doesn't.
Right, x squared here is not the same as these other terms here. Definition of x squared is x multiplied by x, right? The definition of x cubed is x multiplied by x multiplied by x, yeah? X to the power 3. So these here are not the same as x. So be careful of that. Now, all these here are like terms because they contain the x in it. If you have an x squared, it's not the same as x, right? So take note of that. Let me give a next example. If you have 7y minus 3y minus 2y minus y, and then you have y squared and y cubed, or even 2y squared, all these are unlike terms. This, however, these are the like terms. These are the like terms because they must have the same exact variable, right? Point to note as well, when a variable is by itself, it understood to have a 1 in front of it, right? Yeah, I'll send you notes for this all right after. Let's pay attention for now, right? So if you have x is the same as 1x, and y is the same as 1y, minus x is the same as minus 1x, minus y is the same as minus 1y. That 1 in front, once I'm allocated by itself, the understood coefficient or the understood number in front is 1. So this number in front is called the coefficient. What is it called, Colin?
It is called the coefficient.
The coefficient of this first term is 3. The coefficient here is 5. The coefficient here is minus 7. The coefficient here is 2. The coefficient is 1. The coefficient here is minus 1. It is understood, right? The coefficient here is minus 3. The coefficient of this term is a whole term, but the coefficient is minus 2. So I want you to understand the terms, right? We learned 2 new words today. Well, you probably know it before, right? If not, it's revision for you. coefficient. Coefficient is the term that is multiplied by the variable. So when something is attached together like this literally means 2 multiplied by x, which is forms 2x, right? Minus x is like minus 1 multiplied by x. Multiplied by x. So you see the x is written different for the multiplication side, right? Yeah? Good. There's a lot to take in, but all this here is what we learn in algebra. You still need to be familiar with in algebra, right? Good. Do you understand this, right? How x is the same as 1x, y is the same as 1y, etc., minus 3ab, right, is the same as minus 3ba. Now, ab is equal to ba. Why this is so? A multiplied by b is the same as b multiplied by a, right? Pay attention to this. 3 multiplied by 2 is 6. 2 multiplied by 3 is 6. This is a law in mathematics called commutative law. Commutative law simply states a multiplied by b is equal to b multiplied by a, right? This works on multiplication, right? But we're not going to in detail of the commutative law. So, Colin, look at this. 6xy, 7xy, 4x squared, and minus 2yx. Colin, are all these like terms here? Yes or no?
Good. Those are not items.
What is the unlike one here? What the unlike ones?
X squared.
4x
4x.
squared. Good. These are unlike terms. Right? What about the others? The others good?
No.
Which one again?
Two. Well, like, I think all of them, because like all of them have a y in it.
All have a y, all have a x. So what I want you to pay attention to, 6xy is 6 multiplied by x multiplied by y. 7xy is 7 multiplied by x multiplied by y. So the variable here is xy, the variable is xy. This one here, students, although it doesn't look the same as this, it is a like term as well, because it's minus 2 multiplied by y multiplied by x. So xy is the same as yx. These two are like terms. So this is a like term with this and with this, right? Yeah, but we prefer to write it xy because we prefer to write it in alphabetical order. You write the lower letter first, man. Right? If you have a multiplied by b, you can write it like ba or you can write it like ab, but we prefer to write it like this way. But both ways are correct. Yeah? Both ways are correct. So, understanding like terms, right, is the first step to doing the topic today, right? So the topic today is simplifying like terms, right? So, this is a note here. You can take this down in your notes when you take it on your notes later today. We can simplify like terms using the laws of directed numbers. And what are the laws of directed numbers? Same signs and keep the same sign, different sign, subtract and keep the sign of the bigger term, the heavier term, right? So let me give an example now. 3x minus 7x, right? Are these like terms here, Colin?
No, sir.
Why they not like terms?
They are like terms, sir.
They are like terms. Can we simplify them using the laws of directed numbers? Yes, we can't simplify them because they are like terms, right? So you're going to apply the different signs law here. Subtract and keep the sign of the bigger one. 7 take away 3 is 4, so the answer is negative 4x. You understand that, Colin?
Yes, sir.
Good. Alan, in class today? Oh, Alan not here yet. Tristan, look at this one.
Yes, yeah, yeah.
Right. Tell me, are these like terms, Tristan?
What's it? Yeah, on my side, your screen freeze.
Yeah. See now?
What you mean, sir? What you mean? Which ones?
Minus 3x minus x minus x.
In the example, right, is it?
Yes.
Yes, sir, they are like terms.
Right. So what we want to do here, we can write it back as minus 3x minus 1x minus 1x. We can simplify them using the laws of directed numbers. So we say same signs, add and keep the same sign. 3 plus 1 is 5, so that is minus 5x, right? There we
Yes,
again,
sir.
2ab minus 7ab plus 8ab minus 15ab. Can we simplify this here now, Tristan?
Yes, sir. So
All like
basically,
terms,
2 plus. Yes. Yes, sir. They are all like terms, sir.
right? So help me out. What are we gonna do?
All right, sir. So the first thing we can do, we can add them. So I can go with the easy ones first. So 2 plus 8 equals to 10, and then 7 plus 5 equals to 22. So 22 plus 10 equals to 32.
All right. Hold up. We simplify these
32
two
AB.
first. We get 10ab. And
Yeah.
then we simplify these two after, and they get minus 22ab. Yeah?
Yeah.
Nice. Now we're gonna apply the different signs law. Everybody agree? Who agree we're gonna apply the different signs law now? We apply the same signs law here for in SS for same sign, SS
Yes,
for
sir.
same sign. Now we're gonna apply the different signs law here, right? Now
Well, all right,
Tristan,
sir. So since the 22 bigger than the 10, it will be 10 take away 22, which will be 12, which will be negative 12. Negative 12 AB.
excellent work, right? Yeah?
Yes, sir.
Everybody understand these examples so far? Show your hand by the show of hands. Does everybody understand these examples so far? Right? Yeah, I don't want to go too fast to make sure anybody get left behind, anybody don't understand, please let me know now, right? Yeah. We have a few minutes before the meeting done. I want to do a few examples again. After the end of the examples, I'm gonna put some questions for you all to do. Right? Now you can't rush this topic. You gotta take your time, right? And make sure you understand it now. Because if you don't understand this, you can't move on in algebra. Nothing else in algebra we cannot do unless you understand this topic, right? So let's go on to the next example, you know. The next volunteer, somebody who didn't know answer a question here. Vishesh.
So, yeah.
Yeah.
I was about to tell you, a man with up here and vicious, whatever his name is.
Right. Yeah, Vishesh. Are there any like terms here, Vishesh, in this example? Look at it.
Yes, sir. Yeah, except for x squared.
Except for minus x squared, yeah? Good.
Yeah.
Right. Tell me a plan how to simplify this now.
We have to add the negatives, which is equal to negative 11,
Negative 11x. Good. Understood.
and we is equal to positive 5x.
Positive 5x. You bring down this negative x squared here. You can put it as negative 1x squared. It
Yeah.
doesn't matter. But we know this can simplify, right? Because I not like to. Right. So we still have to simplify this here because there's x and x here. So right, how are we doing that? What's law we applying? The same
It
sign.
is the different signs law.
Right. Go ahead and
So
apply
it is the heavier sign is negative. So 11 take away 5 is 6, so it's negative 6.
negative 6x. And we will bring along this here.
And yeah.
Right, minus 1x squared. Good. So we can simplify like terms. The note says we can simplify like terms using the laws of directed numbers. Right? There's a next note here now when you're writing on your notes. We cannot simplify unlike terms. So we leave them as is. You understand what as is mean? You leave it as is. Yeah? Right. Then we'll do our next example here, students. And then we go end the meeting. I'm going to send back a second link for you to join back. And I'll give you the questions to try, right? Yeah. Good. So if you attention to this example now, right? We have 3ab minus 7ab plus 2ab plus 2a squared minus 7a squared minus 9 minus 7. There are plenty terms here, right? So we gotta look quickly and see which one is the like terms, right? So here what? A sum of these two here using the same signs law. So wait now. AB and AB can simplify, yes. So that's plus 5AB minus 7AB. I bring it down. Right? You see, I bring down everything I counted for. This here I can simplify this one time. Different signs law here. 7 take away 2 is 5, so I have minus 5A squared. I have to simplify this here. Same sign, that the same sign. That is 9 minus 16. Right? Then this could still simplify further. 7 take away 5, then minus 2AB. Right? And then minus 5A squared minus 16. Now I cannot do anything further here. Sometimes people might say you want to simplify further, but we cannot simplify unlike terms. So we leave them as it is. So this is the answer here, students, right? We did the best here. We simplify the ABs, right? You did it once here with the same signs law, then you apply the different signs law. We get that. We simplify A squared, and simplify the constant terms, right? And you get this, right? So this is the answer here. And that's it. We have some practice questions to do now, right? Any questions?
No, sir.
No, sir.
All right.
No, sir.
No, sir.
You're ready to remember link number 2?
Yes, sir.
Yes, sir.
Now,
Wait, sir, what's link number 2?
answer it now. Yes, it does it. Right?
Oh,
Now, I'll have to write down these notes, yeah? So, where's the plan now? I'll have to write it now, or I'll have to write it after class?
Right.
no, sir. No, sir.
No?
So, yeah, no.
All right, so I'll put it for letter right now, right? And then I'll send the questions for you, right? So let me see if I'll send link 2 now, right? Because you still have some time for class. Right? Yeah, and also send link 2 on the chat, right? Can you see link 2? Right. So you can rejoin with link 2 and we'll continue from there, right?
Okay, sir.
Yes, sir.